The next iteration of Apple's Mac Mini hardware lineup is shaping up to be one of the most unconventional product strategies the tech giant has attempted in years. Recent rumors and supply chain leaks point toward an unusual configuration split, where the entry-level Mac Mini receives the cutting-edge M6 system on a chip, while the premium Mac Mini Pro model retains an M5 Pro processor. On paper, putting a newer architecture into a cheaper machine while charging a premium for an older chip generation appears backward. However, analyzing Apple's hardware constraints, thermal dynamics, and corporate shift toward localized artificial intelligence reveals a calculated design choice. The primary factor driving this strategy is thermal management inside the Mac Mini's compact aluminum enclosure. Unlike larger workstation towers or modular desktops, the Mac Mini operates within a tight thermal envelope with limited space for passive heat sinks or large active fans. When high-performance processors run sustained heavy workloads, such as high-resolution video rendering, complex 3D modeling, or continuous local AI execution, they generate significant thermal output. Over long durations, thermal throttling reduces processing speed to prevent hardware damage. By introducing the M6 chip to the entry-level model, Apple prioritizes performance per watt and overall thermal efficiency. A newer silicon architecture manufactured on a refined process node can achieve higher processing efficiency while consuming less power and producing less heat. This is critical for everyday consumers, students, writers, and general productivity users who benefit from silent, cool operation during multitasking. Rather than aiming purely for raw compute speed on the base tier, the M6 allows the compact desktop to execute system-level operations, drive external displays, and run background processes without triggering aggressive fan profiles. At the same time, this strategy accounts for the heavy compute demands of modern artificial intelligence. Apple has progressively pivoted its operating systems to emphasize on-device machine learning tasks. Features like contextual text summarization, audio isolation, real-time photo enhancements, local voice synthesis, and intelligent automation require persistent neural engine activity. Running these operations locally protects user privacy and reduces latency compared to cloud-based alternatives, but it places a continuous load on the system. An efficiency-focused M6 chip allows these neural tasks to run seamlessly in the background without causing the computer to overheat or consume excessive power. Conversely, retaining the M5 Pro chip for the higher-end model serves users who require raw parallel computing power over raw architectural novelty. Processor generations alone do not dictate absolute performance. A previous generation Pro-tier chip typically features significantly higher GPU core counts, expanded memory bandwidth, more performance cores, and support for higher unified memory capacities than a standard next-generation base chip. For creative professionals editing multi-stream 4K or 8K video, compiling massive software projects, or running dense simulation software, the M5 Pro will still deliver far greater sustained performance than a standard M6. Thus, the product line differentiates between efficiency-driven architectural generation and raw multi-threaded compute capability. Alongside processor updates, leaks indicate a long-overdue change to the baseline hardware specifications, doubling the standard storage capacity from 256 GB to 512 GB. For years, the 256 GB entry-level tier faced heavy criticism from consumers and reviewers alike. In modern workflows, 256 GB fills up rapidly once the operating system, core applications, cache files, and basic media libraries are stored locally. Users frequently ran into storage limitations, forcing reliance on external drives or cloud storage subscriptions. Moving the baseline to 512 GB gives everyday buyers adequate headroom to install large application suites, store local project files, and handle system updates comfortably without immediate storage anxiety. However, these hardware upgrades come with trade-offs regarding release timing and retail pricing. Component supply chain bottlenecks, particularly surrounding advanced unified memory chips and refined semiconductor manufacturing nodes, are reportedly pushing production schedules back. Rather than a near-term release, market estimates suggest the new Mac Mini models may not ship until late 2026 or early 2027.